welcome everyone. This is the next installation of Oracle JSON in the Oracle database. And Beda is going to show us some cool stuff here. I'm going to turn off my camera, mute my phone, or my audio, and I will be monitoring for questions. If you have a question, questions go here. See a little chat pop up right there. Just type your question in the chat box, and I will break in every now and then if there's a question to pass it on while Beda does his thing.
Okay, cool. So today we're going to work just with LifeSQL, and I already uploaded the scripts to LifeSQL, so you should be able to find it later once it's made public. So just look for JSON generation from relational data, or the AskTOM with today's date. And for the ease of use, I will not run the script here because then it would run all of it. Instead, I open another LifeSQL and we're going to look at instructions individually. So if you haven't used LifeSQL before, just go to lifesqloracle.com, and you can either, we just go back here, you can either view existing tutorials. There's already a bit on JSON, but it's not limited to JSON. It's basically all Oracle SQL and related things. Or you can just type your own statements here if you want to try out something. So this works, I think, on an 18 database. So we do have quite a bit of JSON functionality here. So today I will explain how you can, what we would call, modernize a relational application. So think of a legacy relational application, a lot of tables and columns and existing applications that sit on top. But maybe you want to add or modernize a front end by using Node.js and web browser and JavaScript. And you don't want to rewrite the entire application, obviously. Instead, you just want to put a nice looking layer on top. So then it would be ideal if you could get JSON out of your database to the web browser or to the Node.js server, because that's the most easiest format to understand it, and also send JSON back to the database and then update or insert into your relational tables. So what I've prepared here is, so this, we have to basically set up some tables here. So we have an employee and a department. This is what you typically see under the Scott Tiger schema. You have an employee. Employee has a number and name and a job and a manager. So the manager is basically a reference to the ID of the employee table back. And people work in a department, so you have another foreign key to a table, which is called department. This is quite easy, and I would guess that people who work with Oracle know the schema. Now we're just going to insert a bunch of values here. They're not really that interesting. I just want to make sure that there is data we can work with. So let's insert a couple rows here. So basically on top, I paste the SQL statements, then I click run, and in the bottom window, I see the result. So what we see here is that a bunch of values got inserted. So let's take a look at it. I just do a select star from both of these tables here. And we see that we do have in our employee table, we have 14 people and we have 4 departments. I took the liberty to change the job descriptions because some of them were kind of older. So now this is our starting point. We do have an existing relational application. There is no JSON here at all. And what's the easiest way to get this data back as a JSON value? So the easiest thing would be to turn every row into a JSON object, where we take the value from a column and associate it with a field name in JSON. So this is the JSON object constructor function. And we say we want to have a field which is called ID. And the value of this field shall be the employee number. So this is the reference to this column here, empno. Similarly, we have the name, the job, and the hire date, and the manager ID as the value which we get out of this MGR column. So if we run this, we basically get back the JSON. So it's as easy as that. So we see the ID and the corresponding no value and the name and the corresponding name from the table. We also see the hire date. And this is the first thing that's interesting. The dates in JSON that we generate are all ISO 8601 dates. So we do not really look at the NLS settings. So if you have a database in the US or in Germany or in France, whatever different date formats exist, they don't have an impact on the JSON that we generate. And the reason we do so is that if you receive such a JSON, there is nothing inside the JSON which would tell you any date format here. So this is why ISO 8601 helps here, because there's only one way of representing the state. Good. So that was the easiest thing. We get one JSON per row, but let's say we wanted to get one JSON that captures all our employees. So we want to turn this into one array, one value. It's easy. We basically take the same JSON object that generates the object, and we put an aggregate function on top. And in this case, it's the array ag. So we want to take all these objects and put them inside an array. And that's the result. We get one row back. It's a long row. And we see that the first character here is the square bracket. And that shows us that the array starts here. Then we do have the object, comma separated from the next object. Good. So we already covered JSON object and JSON array ag. So now let's say I want to pull not all the data, but just one record. Well, that's, again, extremely easy. We just add a where clause where we want to look up one specific record. So here we get Mr. Clark or Mrs. Clark, who's a manager. And we see there is this field here which points to the manager of that employee and gives us a number. Well, that's obviously possible for us now to go back to the database and issue another query to get information about the manager if we were interested in the name, for example. But how could we do this in one step? Well, it's quite easy as well. Again, we would just query this table twice, do a join on the manager. So we have the employee table for the employee, then the employee table for the manager. We have this join condition that the employee number should be the manager, and then we can basically pull out the manager name from the corresponding employee, which is the manager information. And now we get back the object, and in addition to the manager ID, we also get the manager's name. So in this JSON, there is nothing telling us that we did a join or a self-join with the same table.
Question right there.
Yeah.
JSON object, is that available from 12 CR2 and later, or is there an 11G version as well?
Oh, there is no 11. All the JSON stuff started in 12.1. And we did had 12.1, I think, JSON, not the ag functions, but just, no, let me say, this might have been 12.2. But in 12.2, you should get the JSON generation functions. There were some limitations regarding returning CLOB values. But I think that would be fixed in 18. So all that I'm showing here relies on shorter values, so CLOB does matter. So it should work on 12.2. So basically now, given an employee, we're able to look one level up. We can include the information about the manager. But what if we wanted to have the information about the reports or the number of reports someone has? Well, it's again, I mean, these are all slight modifications of the same query that I'm showing you. So we add a field here which is called num reports, and its value is basically the result of a subquery. So we issue a subquery again from the employee table, and we look for the people whose manager is the current employee, and we do a count star. So we count the number of employees that a person have, and we see that Mr. Blake is Mr. Blake's manager is king, but Blake itself is the manager and he has 5 reports. Now, just having the number of reports is not so interesting. What if we wanted to see the people that are reporting to that person? So what we do is, instead of counting, we would just, so the count value basically is a 5. This is the result of the 5. But if we just replace this part with a JSON array ag, we get all these people's name, or the people that are reporting to the person. So we know that Blake has these 5 reports, and that is the name of these people that are reporting to him. Now, let's beef this up furthermore. This is just the names of the people. What if we wanted to have really objects for each employee with a little more information, like the employee ID? Again, we're just drilling into the array ag. Just copy this. So instead of having an array ag, I'm replacing now this here, the name, with an object. So we have our array ag, but instead of having just the name here, we generate a nested object. And for each object, we want to have the name and the ID and the job. So now in our reports here, we say this is still an array, but instead of just having the name, Ellen, and Word, we now have individual objects for the people that are reporting to Mr. or Mrs. Blake.
There's another question there. It says, I can extract the file name of varchar250 from the JSON object stored in the database as a clob, but how do we extract the image of a clob 10,000, which is base 64 decoded, stored in the same object?
Sorry, I have to go to the chat. This was
it's probably easier if you read it.
Yep, I just have to find the chat here.
Go to the top of your, since you're sharing, go to the top of the screen and just hover up there and it should pop up in the center.
Oh, got it. Yeah, I see it here. There is the more, and then there is the chat. Yes, I can extract file name varchar250 from the JSON object stored in database as a log, but how to extract image? So this is a JSON value question. Has nothing, maybe this is a bit unrelated from generation. This is about extraction. If it's fine, because this will take a few minutes to explain. Let's just do this at the end. Can you remember this, please, Blaine? Yeah,
sure.
Let me just continue my show here. So now we were able to basically generate these employee objects with information about the manager and the subordinates. We could also, using a connect by query, this is kind of the last query in this series of examples, we could see who are all the people who report to a person. So we do have a connect by query here where we start with one employee, and we want to find not only the direct reports, but recursively also the reports of the reports. So we, if this was not a JSON query, the query I think would like this. So this is the plain relational result. We get all the people who somehow report to the CEO of this company using a connect by query. And all I do is I turn these rows, these 14 rows, into one array by putting a JSON array ag on top of it. This is actually how I write most of these queries. I first write the relational part of it that extracts the data that I'm interested in. And then later I put these JSON object or JSON array eggs on top of that. And then the relational result is just turned into JSON. So the skills to write a SQL can be totally reused, and just because it's JSON doesn't really change much about writing the SQL. Okay, so far we've only worked with one table, which was the employee table, but we have another one, the department table. So similarly, if we wanted to have the department name in our employee information, we would just also select from the department table. We do a join. All this happens in plain relational concept. And then we just extract the department name, and we will get the values from two tables in one JSON object back. And I think this is really the nice part about these JSON generation objects, that they totally work on top of all the relational concepts. So if you have a group by or having or order by, if not what, that is all working fine with JSON. So there's one more operator which is called JSON object ag. So far, if we've generated these objects, these field names were always constant and they were part of my query. So I basically wrote department as a varchar string before this values clause. But with JSON object ag, I can also generate dynamic field names. So let's just run it. It makes it maybe more easy. So we do have these 4 different departments. And object ag, again, is an aggregation function. So it turns multiple rows into one row. And here it takes the key name from the relational result or from a column value directly. So the 10 was part of this table, and its value is the department name. So it's a column value here. So now you may ask, why is there a toChar? Well, the reason is that department number is a number, and an object field is supposed to be a string or a varchar value. So this is why we just do this conversion here, and you see the result that there are these double quotes. Now, there's a little not oddity, but something to keep in mind. So what if the field name, this department number, was not unique? So you see here we have 10 to 40. These are all unique values. But what happens if that's not the case? For example, what if my field name was only occurring once, or it was repeated in the row? So then we basically only get the last one. So intermediate values get overwritten. So this obviously is not good in some cases. So what you can do to check for this is you can say, well, I want to make sure that while I'm building this object, that I'm not overriding any keys that I've already used. So you add this with unique keys clause there, and you will then get an error. So there are duplicate key names in your JSON object. But if I basically go back to what I had before, just copy this in to stuff here. So the department number, this was the first object ag query we ran. And you see here that this check with unique keys succeeds. There are no duplicate keys, so this works. Obviously, this takes a bit of time to check that the key names are not overwritten. This is why we don't do it by default. Let's say part of our modernization included a new table, which was JSON itself. So we have our employees, our old legacy application, but now we want to offer people a way to have a profile or have some skills which they want to put in the database. And because this is a new project, we want that to be stored as JSON. So, and we use the collection mechanism that I've shown you in the last video. So we create a collection here. Actually, no, this is drop collection, which is probably fine because we don't have a collection yet. So let's create a new collection. So we want to have a collection or a table called emp profiles. And in the last AskTOM Office Hours, I described all this collection business. Basically, it's a system maintained table, which has typically a key and a value, and the value is JSON. And here in this metadata, I actually say the key is associated with a column called key, and I'm providing the value for the key. So the client is providing the value, that the database is not maintaining the keys or not creating the keys. And I have my content column, which is called profile, and the SQL type is varchar. And in the last office hours, I've shown how you can use Java and REST to access it directly. So for this example here, just think of this to be a little fancy create table statement. And we also going to insert something into this collection. I also use PL SQL here. So we have this, we open our M profiles collections and we create a document, which is it's basically an object which has a field skills. And inside skills, I list a few strings for Java, C, and PL SQL. These are the strings that we associate with this employee. So this is the key. And then I insert this document. And I repeat this step 2 times for 2 other employees. Yes, it does. So we select from this collection / table. And we see that our key holds a value, which also is a valid employee ID. So this is the way how an employee can, or is the relationship between the employee table and this profiles table is done through this employee number and the key. And then people can have an object here, JSON object with the skills array. And because this is JSON, they can obviously have other keys there, like, I don't know, photo URL, or some little text, keywords, whatever, kind of similar to this flex field use case. Now my phone is ringing. So now let's say we wanted to also include this. Well, let's go back to these to this query here. This was our employees information table, and now we have another field called info, and that is the profile information that we had in our profiles table. So why does this only show 3 rows here? We had 14 employees. Maybe someone can answer that in the chat. This is now a question if some people are listening. We have 14 employees and this query only returns 3 rows. Why is that the case?
Do they all have profiles?
No, most of them have null values, exactly. That's the point. So we would need to turn this into an outer join, and then people would have a null value here. The other thing that you see here, this is actually what I want to show here, is that our collection was storing this JSON as a varchar 2 value. So this here, or if I go back to the profiles table here. And this is basically a varchar 2 value inside the database. So it's a string. So the question now is, if we pick this up, in here we say info, there is a field called info. Its value is profile, and profile comes from our employee profiles table. And if this is the string, you would guess that there are double quotes around these colon, because normally if you generate JSON, any string value get put into double quote. So the reason it is not done is because the data originates from a collection and there is an is JSON check constraint on it. So the database knows that our emp profiles collection or table stores JSON data. So it knows that this object is JSON, and therefore it is not double quoting it. But let's say we have a string value where we don't know if it's JSON or not. And I make this very easy. I just create a function called foo. Mathematically, it would be called identity function. So we pass in a string value and we just return the value. It's not doing anything with the value. And now I run the same JSON object generation function here, but instead of profile, I just call foo of profile. So I round trip it through this function, and you can see here now the double quoting is happening. So this was a string or a varchar value where we don't know that this is JSON, and consequently we have to double quote. So this, you may run into this if you have either JSON in a table which does not have a JSON or is JSON check constraint, or if you have some microservice architecture where you have PL SQL or other functions that return JSON as a varchar or CLOB, then you don't know, then the database doesn't know when it's ingesting this new value that this is actually JSON. So the way you solve this is that for each value, you can say this is actually JSON using the format JSON clause. This is what we standardized in the SQL JSON standard. So now you're telling, well, info get its value from this expression, and it is actually JSON. Now you see the double quotes are gone. This is kind of a manual override. And what you may run into now is that what happens if the value is not JSON, like I am not JSON. So if we run this, we will see that this is actually no longer valid JSON that's being generated. So although we have the output of the JSON object function, its result is not valid JSON. And the reason is because we honor this override. The user has told us this is JSON, so we trust the user. Sometimes you shouldn't be doing that. Sometimes it's better to test it, that it's actual JSON, and you do this by adding this keyword strict. So this means we're honoring what you're saying, that something you give us is JSON, but we don't really trust you, so we're going to check it as well. So now if you run it with the strict mode, then you get a syntax error. Whatever you generated is not really JSON. If I replace this here, let's say with an empty object, which makes it valid JSON, we should now not see the error message anymore, but instead this empty object. So if you're sure that a value you're getting is always valid JSON, you may omit the strict clause, because that will save you some performance because you don't have to do the validation. But in cases where you're not entirely sure, you may want to put the strict keyword in here. Good. Now we're getting to the point of inserts and updates. So what I've shown you so far is basically two things. How can you get JSON out of pure relational data? And second, what if there is a bit of JSON? You can actually merge JSON data and relational data and see it all as just JSON data. Then you ship it to your mid-tier, Java, Node.js, whatever. You may do some JavaScript logic there, or even ship it to the web browser where it gets visualized in a nice HTML page. And now let's say we want to go the other way around. Let's say we have an application where people can change some of their attributes. Let's say a person gets married and want to change the last name. So let's say we want to provide a possibility for name change. So let's say that this is what the database receives as a workload object. We want to say, well, the new name of employee 7934 should be Patel. So this obviously could be handled by the mid-tier. You could write some Java code that does an insert or update statement, but I want to show you one way of running this inside the database using PL SQL. So I'm creating a procedure here, which is called rename employee. And let's just copy this workload in there. I'm going to remove it before I execute it. So this record here would be the one in line 1. I have these two variables, ID, which is a number, new name, which is a varchar, and I just extract these values out of my record. So ID is a JSON value extraction with a path expression $.empNose, so it extracts the 7934, and similarly the new name is extracted by this path expression. We just execute this PL/SQL procedure, and now I can invoke it. So think that this is now called from the mid here, but I'm just invoking this procedure here from SQL. So I'm calling rename employee with this employee number and the new name. And if it succeeded, we should be just seeing a different name. If we say select star from emp, I think Miller got renamed to Patel. There it is. Quite easy. Now, how do I update the skills? This was data that we had in, what was this, emp profiles, right? So here we had our other table whose payload was JSON. So here I cannot just overwrite this profile data with a new value unless I want to fully replace it with a totally new value. But normally if someone wants to add a skill, they want to inject it into this array. So this is a bit more work. So again, let's say this is our payload here. We want to add a skill for the employee 7934, and the new skill is that this person's great at YouTube videos. So it most obviously wouldn't be me. So again, we write a bit of PL/SQL. It's a bit longer now. You could combine probably some steps into one line. I just kept this separate here. So we have our add skill procedure. Again, the value provided is called record here. It's what we have in line 1. The variables I'm using again is the ID, it's the number, it's the skill that we're adding. Then I have to extract the profile value as a varchar. And then I use these JSON object T and JSON array T built-in object types in PL/SQL, which allow me to interact with the JSON as we see in a second. So again, I extract the ID value using JSON value and the skill value. So basically then ID will be 7934 and skill will be YouTube videos. Now I select the profile, this varchar value from the table, given the key that I extracted before. Now this is the parse operation. This parses the JSON serialized or the JSON varchar value into an in-memory JSON tree or DOM tree, how we call it. I extract the array. So basically, this is the this is the object. I would extract a nested array. I don't see it here in line number 1. It's it's here. So I extract this array. And now to this array, I append a value, which is the skill. Then I turn it back into the string representation. So far, all the update has been done in memory. And then once I have the string value, I can update the underlying column value. So let's just run this in here. And we call this procedure. So we execute it with employee 7900. And this guy is now great at making YouTube videos. Now if I select the JSON record for that person, we see that the skills array, which used to be only fuzzy testing, now also has YouTube videos. Okay, so this is one way of updating your relational and JSON data, giving a JSON payload object. So that concludes my demo here, and I'm open to question. And I remember we already had a question here. I can extract a file name that's like a short varchar 50 from a JSON object as a C-log. Okay, so this would be JSON value returning C-log, but how do I extract an image? So it's a base 64 decoded in the same object. I would guess, or the question to Smashikar would be, that's probably a string value, right? It's the image is base 64 encoded, but the JSON will probably basically it's a base 64 image encoded as a string in the JSON. So yeah, returning CLOB should work on, it would be JSON value, you'd have the expression, and then the clause would be returning CLOB. So I'm just replying to here. Oh yeah, and it says it returns null. That's also a good thing. JData pages image. So I'm typing now returning CLOB. So if you don't specify a returning clause, the default is varchar 4000. If it's longer than varchar 4000, it's actually an error. The buffer would be too small, but then the null on error behavior kicks in. So if you get null values back from your JSON operations, especially JSON value, what you want to do is just run error on error. I'm just replying again to your question. So if you specify error on error, then any error that's happening inside, let's say this buffer too small, or if you want to return a value as a number which is not a number, then these errors are actually being raised. Normally they're suppressed by returning you a null value. So now you may ask, why are we not raising an error by default? Why do we have this null on error business? And when we designed the SQL JSON standard, we looked at a lot of public JSON data that's out there, and we've seen that in the schema-less or schema-flexible world, you may find objects which for some reasons, I don't know, maybe a bug in the generation or something else, are not entirely correct. So if you have thousands or millions or billions of records and you have a query which runs very long, then these outliers should not abort your query execution. It would be very frustrating if your query runs for half an hour and then it just aborts because there's one dirty record, and then you would have to go and find this dirty record, remove it, and run it again. And because we've seen these examples, it was one of the requirements of the SQL JSON standard to be somewhat fault tolerant, to not immediately error out. But you can always go to this stricter mode by writing error on error. So I hope that answers this question. Okay, it seems so. Thank you. Good. Any more questions? We're basically through the parts that I wanted to show this time. I'm also open to suggestions for one of the next AskTOM sessions. So if there's something you want me to explain, please just shoot me your ideas or requests.
And if you come up with something later on, you can also log on to the AskTOM page for the office hours session and submit your questions or suggestions there after we're done.